Okay, so we're going to take a look at a couple examples applying the area formula. Right now, the first one is a straightforward example. So we're given a triangle 10, 10, 12. Right. So what we have is an isosceles triangle, right? And we want to find the area here. Right. So again, the area formula is 1/2 base times height. Okay, now if we were to drop a perpendicular here, one thing to note that if we do drop this perpendicular, then this has to bisect that line segment, right? Because remember, these angles are going to be the same, right? They share this side, right? And then this side is 90, so these angles have to be the same, which means these sides here have to be the same. So here, this side is 12. And these sides here must be 6 here. Okay, so that's going to help us to determine the height of this triangle here. So here we have the height is going to be, since this is the hypotenuse, 10 squared equals to 6 squared plus h squared. So simplifying this, we get 136 plus h squared. Subtract 36 from both sides. 0, and we get 64 equals to h squared. Taking the root here of both sides, we get the height is equal to 8. So that is the height of our triangle. All right, so now we can find the area, right? The area will be 1/2 base times height, and the base is 12. Excuse me. So 1/2 base is 12, and the height is 8. All right, so simplifying all this out, right, 1/2 times 12 is 6 times 8. We get 48. And we get units squared. Okay. All right, so that's how we approach that problem. Again, knowing what we've covered previously about isosceles triangles and dropping a perpendicular. Okay, so now let's take a look at a slightly different type of problem. So for this problem, let me draw the figure here. Okay, so here, let's say that this is so the height here is x, this value is x, and this one is 2. All right, and we're asked to find x if the area on here, A, C. Find x if area of triangle A, B, C is 12. Okay. All right. So we know what the area is equal to, right? We know the area is 12. We also know the area formula for our triangle is 1/2 base times height. Okay, so looking at this triangle here, our base is going to be x plus 2, right? The whole base. Remember, the triangle ABC is these two kind of little triangles put together. So we can set something up like 1/2 base is x plus 2. And then the height is x equals to 12. Okay, so one thing we can do, and there's a fraction here. Right away, I like to say, let me just get rid of this fraction here. So I'm going to multiply both sides of the equation by 2. So I'll multiply this by 2, this by 2. So what that does is this eliminates this fraction, right? This reduces to 1. So we're left with x plus 2 times x equals to 24. All right, and now let's distribute this x here. So again, it looks like I have a quadratic. So I'm going to set it equal to 0. So the first step here is distributing that x squared plus 2x equals to 24. Subtract 24 from both sides. All right, so there's no like terms here. Okay, so we have a quadratic, and again, as always, quadratic formula works just fine here, but I'm going to try and factor this, which I can here. So looking for two numbers that multiply to negative 24, but add to a positive 2. So x, I think 6 and negative 2 works. Excuse me, 6 and negative 4, not 2. Okay, equals to 0. So that means, based off of this, I have two solutions. X equals negative 6. X is equal to 4. All right, so algebraically, this makes sense, but I do need to make sure in the application that I'm using it, we're dealing with lengths, so it doesn't make sense to have a length of negative 6. So I'll reject this answer, and we have a solution of x is equal to 4. Okay, all right.